Okay, so hey everyone, I'm Nathan LeClaire, Solutions Architect with Honeycomb here, and today we're going to talk a little bit about how you can use Honeycomb to achieve production excellence. So just a little example we'll be going through. You can see some instrumentation code here where we're starting a span, which we'll be using to track what's going on in Honeycomb tracing, adding some fields on that describe properties of what's happening in this little chunk of work here. And we might even nest other spans inside of it. So that's what this beeline.start span call for this API call is in the middle here. And at the end, we close everything up and send it along to Honeycomb, where we can visualize what's happening in our system using the extremely fast data engine that we have at Honeycomb. So because of the sophistication and high dimensionality, we can answer questions that you have about what's going on in your system in seconds. And here we do have some golden signal graphs that are representing what's going on in production. You can, for instance, see that we have this little crop up in latency and also in the amount of errors happening here. But that's not what's really exciting and special about Honeycomb. What's special about Honeycomb is that you can analyze the data in a lot of detail. So for instance, we might have an SLO here that we define that says, hey, all of the requests that we are getting to our service need to be happening faster than 1100 milliseconds. And Honeycomb will track over time how well we're doing at complying with that budget. And we can also set burn alerts that allow us to alert when we are in violation of our budget. So for the goals that we've set for ourselves, instead of being fatigued by alerts that are hitting us all the time over all sorts of little details that might not matter, they can alert on the things that we're actually interested in. And not only that, but Honeycomb's bubble up feature will identify what's different about the things that are causing trouble in our system automatically. So here we can see that we've highlighted on this little heat map showing latency, these little chunks of violations of our SLO. And if we hover over the endpoint field, we can see that very clearly this one endpoint, the /export endpoint, is associated 93% of the time with the problem. So it does seem to be this one endpoint that's causing an issue for us. And we can even hover over and see that this one user ID, it's kind of really skinny gold bar here, 2109 is the problem. So we've really rapidly identified that there's this subsection of our data that we probably want to dig into in more detail. And so if we come over to the query builder here, you can see we can execute additional queries really rapidly. I could bubble up again on that little region of interest here. And also probably continue iterating on what we've already done. So here I might want to filter down to just this endpoint. So using the ergonomic query builder here, I'll add on a where clause and maybe group by this user ID as well. So we see everything split out by individual traffic. And we can see that one user seems to be the source of our issues. So even though our SLI was true there, we can see that when we started violating our goals was after this one user was hitting the service again and again and again. So instead of having some static dashboard that we check and hopefully have the right charts on, our SLO page became this constantly changing, ever morphing source of lots of details about what's happening in production. So we super rapidly identified what's happening and why our systems are slow. But if we want to know more about why, we can zoom in with tracing. So if I zoom in on this time chart here, Honeycomb will pull up the associated traces for this time interval. And we can click on one of these trace IDs to learn more about what happens in the lifecycle of one request if we put it under the microscope. So like we mentioned, we saw this call to the /export endpoint. And that started off at the gateway service, which called a couple of other services, the rate limiter service and the auth service. You might recall back to the code instrumentation here. Sometimes this is done automatically by hooking into common frameworks. But at any rate, when it's all done and sent to Honeycomb, it'll look something like this. And we see that there was a couple of really fast calls to these other services. They just made like one call out to Redis, for instance. But then we hit the problematic chunk of our code. So this ticket backend service was really slow. And if we unfurl that, we can see why. It's because we were executing the same type of query over and over and over again. And individually, that may have been fast, but clearly we need to roll that all up into one operation. And we can even take those findings and go back to doing a high-level analysis in Honeycomb, where maybe we group by the db.query field. So db.query might show us that if we sum up all of the latency by the normalized query, we might be able to see a pattern where one particular type of query may not be fast or slow individually, but the queries, when you add them all together, will be very slow, and that could be a source of operational problems for us. So the field limits for Honeycomb are extremely high, and because of our custom-built data engine, we can do extremely sophisticated analysis where we chug through billions of data points in seconds. So give us a shout out and try it out.